Renal regulation of blood pH. pH level describes the acidity and alkalinity of a substance. The pH scale ranges from 0 to 14, the lower numbers indicating more acidic substances and the higher numbers indicating more basic or alkaline substances. The body's normal pH level is 7.35. Homeostasis is any process that helps the body maintain a state of equilibrium during changes to the external environment. Acidosis occurs when an individual has a pH level of below 7.35, and alkalosis occurs when an individual has a pH level of above 7.35. There are three ways to regulate blood pH level: chemical buffers, pulmonary regulation, and renal regulation. We're going to talk about renal regulation. The kidneys control blood pH level by regulating the amounts of hydrogen ions and bicarbonate ions that are excreted in the urine. At the kidneys, blood reabsorption, filtration, and secretion occur in the most basic functional unit of the kidney, the nephron. In the nephron, the glomerulus is surrounded by Bowman's capsule, which leads to the U-shaped tubule and then to the collecting duct. The fluid in the collecting duct empties into the bladder as urine. These ions are able to enter the kidney by passive filtration in Bowman's capsule as well as through transport mechanisms in the kidney tubules. Renal regulation of pH level occurs through hydrogen ion secretion and bicarbonate reabsorption. The body maintains blood pH level through renal secretion of hydrogen ions. Carbon dioxide diffuses into the kidney tubule cells. Carbonic anhydrase catalyzes the reaction in which carbon dioxide and water react to form carbonic acid, which dissociates into hydrogen ions and bicarbonate ions. The hydrogen ions then go out of the cells into the urine. The hydrogen are then buffered by either combining with the phosphate and sodium ions to form monosodium phosphate, which is then excreted, or by combining with ammonia that was also secreted in the urine to form ammonium ions, which are then excreted as well. By excreting an acid, the kidneys produce additional bicarbonate ions. The bicarbonate ions diffuse into the blood. The amount of renal acid excretion equals the amount of renal bicarbonate production. Dropping or rising pH levels stimulate the endocrine system to produce or inhibit hormones in order to return the pH level back to normal, 7.35. This occurs in a negative feedback loop. When acidosis occurs, a signal is sent to the pituitary gland to release ACTH, stimulating the release of hormones by the adrenal cortex. The adrenal glands are stimulated to produce more aldosterone, which causes the kidney to carry out hydrogen secretion and excretion. Adrenergic agonists and angiotensin II stimulate the kidney tubules to increase reabsorption of the bicarbonate in the tubular fluid. Glucocorticoids are also involved in bicarbonate transport. When alkalosis occurs, a signal will be sent to the pituitary gland to inhibit ACTH production, which hinders the stimulation of aldosterone, adrenergic agonists, angiotensin II, and glucocorticoids. Thus, the kidney will decrease hydrogen secretion and will in turn decrease the bicarbonate production and may even excrete bicarbonate in the urine. A disruption in acid-base homeostasis can lead to metabolic alkalosis, which is caused by excessive fluid loss. Renal tubular acidosis occurs when the kidneys do not effectively excrete hydrogen ions and can further lead to kidney disease or kidney failure. Treatments include taking alkaline agents that will return the body pH level back to normal. In summary, when the blood's pH level becomes too acidic, it stimulates the release of hormones to increase hydrogen secretion and thus bicarbonate production. When the blood's pH level becomes too basic, the production of these hormones are inhibited so that the pH level can return back to normal. This negative feedback loop maintains the acid-base balance of the body.
Created using Powtoon.